So we got this cube that we're gonna cut this one first parallel to the base. On this one, parallel to the base is this bottom piece right here. And to cut it parallel, we just need to cut it like if we're putting a knife right here, and then we're going to go straight across. So this would be a horizontal slice. And when we cut this across, well, it kind of takes away the rest of that shape, right?
Yeah.
So now the rest of that is gunner.
Oh, that's cool.
So that's not what I wanted. So now if we look at that red piece right there, what shape is that red piece? Yeah, since this is a cube, if we were to move this so that we could see its face, oh, that's not very good, but it would be a square. Alright, so that cross section gives us a square right here. Alright, this next one, we want this cut parallel to the base again, but at a different distance from the base. So let's go ahead and we'll sketch the exposed surface as well. But let's go ahead and chop it somewhere else. So this is the shape that we have. Before we cut it pretty much right in the center right here, we're going to take that back and move it upwards right here. Now again, I'm just cutting this straight horizontally right here. So now, if I cut this off, like these, then what shape does we have?
Square.
Yeah, it's still a square, so we would still end up with a nice square shape right here. So what is true about all cuts of a cube parallel to the base? They'll always give us squares. There we go. So the second part, what is true about other cuts of a cube not parallel to the base but through at least one lateral face? Again, these will always give us squares as well. Alright, let's move on to this next one. We're going to cut this one perpendicular to the base and parallel to a face. So on this one, perpendicular to the base means it's going to make a 90-degree angle, right account? That's going to make it perpendicular to the base, but also it would be parallel perhaps to this face right account. So when we finish this chop, then we end up with something like these. Let's go ahead and clean that up. This is still a square. If we remove it out here, I mean, it's not very well drawn, but it is supposed to be a square. So yeah, this would still give us a square. Then this next one, we're going to cut this perpendicular to the base and parallel to a face again, but at a different location. Is that going to change anything, you guys?
No.
No. If we did that, I mean, instead of cutting it right there in the middle like we did, maybe we cut it closer to the edge. Yeah, that still will produce a square. How does the new exposed surface compare to the previous surface? They're exactly the same right there. Where we choose to cut a cube, as long as we're cutting it parallel to a face, then it will always be a square. So what is true about all cuts of a cube perpendicular to the base and parallel to a face? Always a square. What is true about cuts of a cube perpendicular to the base but not parallel to a face? In a cube, if it's perpendicular to the base, then it will automatically be parallel to a face. So that's still going to be a square. Alright, so in these ones, we're just looking to see if we can cut this thing up to create different cross sections, different types of cross sections. In this one, we are going to cut this up to make a triangle, and then we'll move on to the square in the other ones. Alright, so I need a triangular face. There's several ways that we can do this, depending on the size of the triangle that we want. First up, what I can do is if I cut this thing, let's say I cut this through a diagonal of one of the squares, and now what I'm going to do is I'm going to cut this diagonally through to this corner right account. what that will do is it's going to create a triangle like these, and then these other pieces kind of just go away.
So did you cut it to like the...
Yeah, so I started by placing the knife here across the diagonal, and then I sliced it straight down into this corner to create
Oh, okay.
this triangle right here.
Oh, alright. I see. Okay.
Now this is what we did, is we started right there, but if for some reason we wanted a smaller triangle, all I would do is place the blade farther to the corner, but I would still slice it diagonally against this corner, and then that creates a little triangle right here. So it depends on the size you want on this, all right? But that would give us a triangle as well, just on that little corner of that cube. What about a square? How do we cut this thing to make a square?
We already did it. Parallel.
Yeah, we did it.
Parallel.
You could cut it, that's not good.
This way.
This way, and then cut it straight back. That's going to make a square. Or you could cut it straight back like this if you wanted to. Either of those would give you a square. Alright, a rectangle is close to the square. And all we got to do to make this a rectangle is to take what would have been a horizontal slice like these, and instead of cutting it straight horizontally parallel to the base, all we've got to do is angle this thing. So instead of cutting it that way, I'm just going to angle it like these. Actually, we'll look at this one. So I'm going to cut this angled right here. So what that's going to do is it's going to cut straight back on at these.
Oh, does that make a square?
And this, now we can see that this side is longer than this side right here. Let's go ahead and clean that up. All right, now what happens is we've got these two lines, and they are parallel to each other, but these edges now are elongated to make this now just a rectangle and not a square. All right, next we need to make a pentagon. So you guys take a moment and see if you can do that. If you can do the pentagon, then try the hexagon thing. Jump it up so that we got a pentagon, but we can only afford to make one slice. Now here's the problem, is if you made two slices, then you got more like a three-dimensional shape anyways, okay? So it's got to be one slice and one slice only. Here we go. What I will do is, I said a pentagon first.
Pentagon's 5.
A pentagon has 5 sides, so something that would be kind of like a regular pentagon looks like these. So I need a shape to look like this. It may be elongated by the time I finish because I'm not perfect at slicing, but I should be able to get this done. Here we go. What I'm going to do is I'm going to take the blade and I'm going to place it right here, but I'm going to slice this thing at an angle right here. Okay?
I see.
Alright, now some of you guys see what will happen, but I'm going to make it so that it comes down to this point right here. Okay? So what's going to happen as I slice downwards, or diagonally, is it's going to make these two lines right here, something like this, and then they will come into that point right here. Let's go ahead and clean this up so you guys can see what the heck just happened. Bam, there it is. This is a pentagon. Now this one is kind of sliced upside down, right? I think it would look something like this. Mine sliced kind of upside downwards. But it is a pentagon. Alright, next up we will make a hexagon by making one cross section or one slice into this cube. This one's really fun. Alright, this one, I made this a little bit bigger so we can see this. So some of you guys noticed on that last one, when we cut up this thing to make the Pentagon, we started about right account, and then we sliced diagonally into this point right account. Well, that made a pentagon. All I want to do now is slice it so that when I end my slice, I'm going to end up on the base right account. So what will happen is I slice downward, is it's going to come to this corner, and then it will come to this corner. On the other side, it would look something like these. And this has 6 sides. Now, let's go ahead and clean this garbage up. Bam, we did it.
Wait, were they really eating pie?
Now, we'll just shade this in so we can see this hexagon. Let's go and draw it on the side as well. Alright, let's go ahead and draw this to the side now. So we got the straight line. We got this portion right account. I guess it's kind of elongated right there, but that's still a 6-sided hexagonal shape. Alright, can we make a circle or a trapezoid with a cube? We certainly couldn't do a circle because there's no way to get a circle out of this with one cut. That is just a cross section. You can't do the circle. That's not going to be possible. I can make a trapezoid out of this thing though. The thing that's unique about a trapezoid is that it has one set of parallel sides and the other 2 sides are not parallel. If they were, then it would be a parallelogram. So let's look at cutting this up into a trapezoid. Alright, so let's take this shape. So to make the trapezoid, what I'm going to do is I'm going to start my slice right here. I'm going to go diagonally, but I'm going to change the angle on this so that it doesn't reach these corners right here. So what that means is I can get down to this diagonal right here. So what happens when I do that is it creates a shape like these. Let's clean that up. And yes, right here we've created a trapezoid. If we drew it separately, it would look something like this. Something like this, where these 2 side lengths are parallel. Mold a right rectangular prism that is not a cube, which we're looking at right now. And the first one, A, it says to cut parallel to the base. So the base on this one we're going to say is this bottom, we'll say it's a square right now. And we're going to cut it parallel to the base, which means I will put a razor blade along this line, and then I would cut straight horizontally.
Oh my gosh.
And now, what have happened?
It looks like it.
Let's go ahead and clean this up, okay? Now here's the problem is some of you guys are still saying rectangular prism. The cross section is not the 3-dimensional shape. What shape did we create? Yeah, this one looks to be a square. A square bottom.
Those sides are not even.
Well, they were supposed to be if I'd used the other one, but yes, this would give us a square. If you said rectangle, that would be acceptable, unless they told us that the base was a square. Alright, this one says cut parallel to the base again, but at a different distance from the base. Alright, let's go ahead and do that. Alright, so I'm going to, last time I cut it about right here. You guys want me to be closer to the base or farther away this time? Farther, okay. So I'm going to cut it, let's say, towards the top up in here. And this is going to be parallel, so I'm going to be cutting this straight horizontally. So that would give me some kind of shape like these. Let's go ahead and clean it up. Alright, so that gives us this cross section right here, which, yes, appears that it would be a square. Now again, I'm okay if you put rectangle on this because it didn't specify that base was a square. Alright, what is true about all cuts of a rectangular prism parallel to the base? So the cross section that we make would be the same shape as the base. But what about, what is true about cuts of a rectangular prism not parallel to the base? Then it depends. It will definitely depend. Alright, so this next part, we're going to take this rectangular prism. We're going to cut perpendicular to the base and parallel to one of the faces. Alright, so we do need to cut this perpendicular to the base. The base is that bottom shape for now. And so what we're going to do is perpendicular would be like placing the razor blade right here, which would make a 90-degree angle with the base. Now when I do that, I'm going to be just cutting straight back into the shape. So this is a horizontal slice, which this shape right here is going to be, let's go and clean that one up as well. So again, we're looking at the cross section right here. And yes, that will create a rectangle. You can call it long and skinny if you want, but it should look something like this. But that is definitely a rectangle. Oh yeah, so when it said to cut it perpendicular, so we made that perpendicular to the base, and we made it parallel to this face here on the left. So that's what that meant by parallel to one of the faces. So we need to cut this perpendicular to the base, but not parallel to a face. This one's a little confusing because if we cut it perpendicular to a base, it'll be parallel to two of the faces. So, I mean, we could make the same cut on this thing. So perpendicular to the base means it's going to create a 90-degree angle with the base. Now in this case, I mean, that's as far as we can go on that thing. So we could say that it's not parallel with one of the front faces. But in any case, we see that it gives us the same shape, the rectangle. So that's our rectangle right there. And we can draw it separately as well, something like this. What is true about all plane sections of a rectangular prism perpendicular to the base and parallel to a face? It will give us the shape that is cut, that it's the parallel shape that it's cut with. Yeah, that sounds good. What is true about any plane section of a rectangular prism perpendicular to the base but not parallel to a face? Now we're looking at spheres. And this first sphere, we're going to cut it parallel to the table at different distances from the table. So let's go ahead and do that. So right here, if I cut this thing, let's say that we cut it first right down the middle, because this would be sitting on a table right here. Well, then we would get this shape. That wasn't good, but yeah, now that's the three-dimensional shape, which if we moved it to the top, we would see that this is a circle. But what if I cut it at a different distance from the table? Alright, so I'm cutting it right here, which also would make a circle, just a smaller one, down at the bottom. So, as it turns out, no matter how far away you are from the table, if you're cutting it parallel to the table, it will always be a circle. Alright, now let's make cuts that are not parallel to the table. Alright, now here's the thing, is if I cut it straight down right here at the top, it'll still be a circle, right? We just changed the orientation of the circle. But what if I cut it diagonally? This is still going to end up being a circle right here. So what if I cut it down diagonally this way? Yeah, still going to give you a circle right here. And as it turns out, it doesn't matter where we cut this circle, we will always get some type of circle. Yeah. What is true about all cuts of a sphere parallel to the table? They're all circles. And what is true about all cuts of a sphere not parallel to the table? Still circles. Now we did make a cut perpendicular to the table already. So let's make this first cut perpendicular to the table. So again, if the table is on the bottom, we're going to cut it straight up, creating a 90-degree angle radical. And that would give us still a circle. Something like this. Now this does look like an oval because of the 3D shape. However, if we took the 3D shape apart and then showed you just the two-dimensional face, it would be a circle. Let's cut perpendicular to the table again, but at a different location on the sphere. So still perpendicular, I'm going to cut it straight across radical. And that's going to be a circle, it's just a smaller circle radical. Same if I cut it over here. That would be a circle, but again, it's just smaller now. I mean, I could cut it here, and it would still be just now a bigger circle, maybe. So what is true about all cuts of a sphere? You always get a circle. Make a cube and rectangular prism. We have those. What is the shape of the base of the cube and the rectangular prism? Will all cuts parallel to the base result in the same planar figure for the cube? Yes. Will all cuts parallel to the base result in the same planar figure for the rectangular prism?
Yes.
Yes. So next up, we're going to rotate these 90 degrees each, which means we're just going to flip them over this way, which is why they're shown in the next two figures right account. So what about now? Now that we've rotated these, what is the shape of the base of the cube and the rectangular prism now? Some type of rectangle. So that's a good question. Would it be a square and a rectangle? That is an acceptable answer. However, squares are types of rectangles, so I'm okay just writing rectangle on this part. Will all cuts parallel to the base result in the same planar figure for the cube? Yes, they will. Will all cuts parallel to the base result in the same planar figure for the rectangular prism? That also is still a yes. You get rectangles right there. So compare and contrast planar sections of rectangular prisms, cubes, and spheres. All right, that seems like a pretty acceptable explanation of that stuff right there. So we're going to take the cylinder. The first one, we're just going to cut it parallel to the base, and we'll see what cross-section this gives us. All right, so this says we got to cut it parallel to the base. The base is kind of horizontal radical. So what we're going to do is cut a horizontal cut on these. So when we do that, what's going to happen is that's not great, but it works. If I cut this off, and let's clean this up, well, then what we get is this red shape, which if we looked at it straight, it would give us a circle like these. All right, the next part is to make cuts not parallel to the base, but through the lateral face of the cylinder. Here we go. Now there's lots of different shapes we can make about this actually, but let's look. All right, so not parallel means that we got to slant this thing just a little bit at least. So if I cut this at some kind of angle now, in fact, let me exaggerate that even a little bit more. I'm going to cut it like these. So I'm going to start at this point with my razor blade and cut it all the way to the top up in here. So if we look at these, it should look something like these. Something like that. Now if we look at this shape, let's go ahead and clean that up. This would actually, if we looked at this straight on, this would be some kind of, you guys would call it an oval maybe. But yes, in math we would call it an ellipse. So this next question, what is true about all cuts of a cylinder parallel to the base? Well, that would give us all cycles. Then what is true about all cuts of a cylinder not parallel to the base? Those are all going to be ellipsi. Bam, there we go. The next part is to cut this perpendicular to the base. Alright, let's get that done. So perpendicular is at a 90-degree angle. So if this was the table, it would be a 90-degree angle up and count. Now I'm going to actually be just placing the razor blade straight across right at count, making a 90-degree angle with the bottom. And I'm going to cut this thing straight across through the middle up in count. So let's see what shape this gives us. Well, this appears to be some sort of rectangle. So let's clean it up. Alright, and if this were a stamp of some sort, then it would clearly be some kind of rectangle up in here. That'll do it. Yeah, nice. Part D, let's make cuts that go through at least one base of the cylinder but are not perpendicular to the base. So what that means is, when I'm cutting this, I'm going to cut through the base, but I'm going to be at some kind of angle up in here. So I'll start on this edge, and I'll place my razor, I guess straight across if I wanted to. And, yeah. If I went all the way to, like, the side over here, then it would create some kind of weird looking part of an oval shape. Something like this, maybe. Now here's the other thing though, is if I went all the way to the other edge, then it would be something more like this. So that'd be just with the edge cut off right there, maybe. So it would be an ellipse with the ends cut off, or just one end cut off. So with these triangular based right prisms, we're going to cut first parallel to the base. Alright, parallel to the base means that I'm going to take my razor blade and I'm going to cut starting with this corner going horizontally straight across. So I could say that I'm going to place the blade across that line if I wanted to. And if I went all the way to the edge, then we would get something, I guess it'd be more like this. Alright, so let's clean that up. Bam. So what shape did we make by cutting this parallel to the base? Triangle. Well, let's go ahead and make cuts that are not parallel to the base but go through at least one of the face of the prism. Okay. So, what I'll do is just like on the last one, I'll still place my razor blade across the edge right here. But there's a couple shapes that we could make. For example, if I went to this corner right here, then, well, I guess that didn't turn out very well. Let me go the other direction. I'm going to cut it down to this point at an angle. So this one is going to create, again, a triangle. But here's the thing, is if I went so that the blade would have cut through this edge right here, or actually let's do it down right here. Well, then the shape would have been a trapezoid. So we get two shapes possible when we do not cut parallel to the base. Bam. It's got to be one of these two. What is true about all cuts of a triangular prism parallel to the base? Well, you'd always get a triangle. Alright, next up we're going to cut this thing perpendicular to the base. Yeah, that'll be good. Alright, perpendicular means I'm going to place the blade of this thing straight up like these, making a 90-degree angle. And I can cut straight back on this thing so that it would create a rectangle. Let me clean this up. Bam. That's going to give us a nice rectangle up in here. What about a square-based right pyramid? Let's make cuts parallel to the base on this one. So if this is my shape, if I was going to cut parallel to the base, then I would need to place my razor blade maybe right here, and then cut straight back. So what would I get by cutting this straight back? Yeah, this is going to be a square. That didn't come out very good, but it is a square. So what do we notice about cuts of a square-based pyramid parallel to the base? They are all squares. Alright, if we cut this perpendicular to the base and parallel to one of the base's edges, then what do we get? So what that means on this is that it would be like starting at the bottom, placing my razor blade parallel to the edges, like this edge and this one. And then maybe I was to cut straight up. Well, if I did that, right in the middle, I get this triangle right here. But if I move the blade anywhere to the side, then it's going to cut up into this right here, which makes a trapezoid. Just like that. So we'll either get a triangle or trapezoid with this type of cut. Next, let's cut this perpendicular to the base again, but at a different location on the pyramid. We already did that. That created either a triangle or a trapezoid, depending on which one we're looking at. So what do we notice about cuts of a triangle perpendicular to the table? You'll either get a triangle or trapezoid with those. So on these ones, make a cylinder and a triangle prism. We just looked at those. Make it a rectangular prism. Orient them like these. That's good. What is the shape of the base of the cylinder? That appears to be a circle to me. What is the shape of the base of the triangular prism? A triangle. What is the shape of the base of the rectangular prism? A rectangle. Will all cuts parallel to the base result in the same planar figure for the cylinder? Yes. Will all cuts parallel to the base result in the same planar figure for the triangular prism? Yes. Will all cuts parallel to the base result in the same planar figure for the rectangular prism? Yes. Rotate each of these 90 degrees, meaning we're just going to set each of them on their sides this way, like in the figure shown down here. So now, what is the shape of the part of the cylinder resting on the table? I would just call that a line. You could say it's a rectangle, perhaps. What is the shape of the part of the triangular prism resting on the table? Right now, it is a rectangle. What is the shape of the part of the rectangular prism resting on the table? A rectangle. Will all cuts parallel to the table result in the same planar figure for the cylinder? Yeah, there'll be rectangles, just they'll be different sizes. What about for the triangular prism? Yes, we're still looking at rectangles, but again, there'll be different sizes there. And then finally on this one, will all cuts parallel to the table result in the same planar figure for the rectangular prism? Yeah, these ones are all the same size rectangles.